You may now begin.
What's up? We're out here communing with aliens, doing problem 1. It's me, Storm from UC Berkeley, and Zach from UCSD. And so yeah, what we are trying to accomplish here is we've run into some aliens and we're on the phone with them, but they don't speak any human language. So we need to find a way to convey some kind of meaningful ideas to them. And so yeah, we want to develop some kind of communication scheme by which we can talk to them and complete these tasks of baking cookies, weightlifting, conveying interesting sentences. We also want to make a computer model of how we imagine we might interact with these aliens. So to begin with, we started with some basic assumptions. They communicate via sound in the same frequency range as us. If they didn't, then this problem would be really hard. They can reply to us and understand when a reply is expected. They process things like sight, sound. They can perceive these things and they know about them. And we also assume that they know about atoms, chemicals, math. They have similar knowledge to us. They just might not be able to communicate with us at first. And that they have comparable environment and physiology to us, so that the things we say about chemicals and about our body make sense to them.
Right, so most of this is going to be a conceptual exercise. We started by assuming they had a similar understanding of math, that the basic ideas of math are universal. So we wanted to start by creating the idea of integers, using a similar schema that Justin and Tiffany introduced, using simply 1 click to denote the number 1, 2 clicks to denote the number 2, and assuming they can follow along in that basic sequence. We would then test their understanding of that basic sequence. I don't know if any of you have ever tutored or managed someone, but if you tell someone something and they tell you that they understand you, they are lying, right? You have to test their understanding out of context to ensure that you're on the same page. Once we have that common basis of understanding, we would move towards basic mathematical operations. So addition, subtraction, multiplication, and key ideas that we would also be introducing here are the idea of equality. And through doing math together, the idea of zero would emerge. So similarly to the last step, we would test their understanding of these. We would then move on to introducing relational operators, such greater than, less than, true, or false, and move on from there. Now, that understanding of integers and mathematical operations gives us the tools to move into the idea of chemical reactions. So we would start by similarly creating a dictionary of atomic elements and trusting that they can recognize the sequence. Importantly, we thought it would be a useful schema to use specific frequencies of sound as opposed to words to denote individual elements. So I could use one individual frequency to denote hydrogen, another individual frequency to denote helium, and so on. And within that dictionary, you would use the unique properties of number of protons and atomic mass units in order to enable them to recognize that we are giving them the periodic table of elements. From there, we would introduce the idea of chemical reactions. And this is, I had to flex the piano, yes, Pablo. I'll do a little sonata at the end, just, to really illustrate the beauty of chemistry. So the idea behind the frequencies is it enables us to distinguish between discrete elements and compounds. So if I gave carbon one distinct tone and oxygen another distinct tone, and playing that chord together would indicate carbon bonded to oxygen. And creating that shared language would give us a schema to start introducing ideas of chemical reactions and chemical compounds. Further, we could also use the amplitude of the frequency to denote the relative numbers. And importantly, chemical reactions enable us to introduce the idea of quantifiable amounts of energy as a product in chemical reactions, which will be important in our next step. which I believe Storm will walk us through.
Yeah, so from there, we want to complete our task of communicating the recipe for vegan chocolate chip cookies. And to do this, we'll hinge off of their understanding of chemical reactions that we now share because we've communicated in this way. There are both organic and inorganic ingredients in cookies. We can specify, the inorganics are very simple. We simply give them the chemical formulas and tell them the quantity. These quantities are currently listed in terms of volume, but we might not actually want to tell them volume. We might actually give them, for example, a number of molecules. For example, this recipe calls for half a teaspoon of salt. We might tell them 5.5 times 10 to the 22 sodium chloride molecules. And we could do this with other molecules similarly. And for the organics, we know that they are also composed of some well-defined molecules. At least we know the major breakdown of them. And so what we could do is we could describe the ratios of these things that come together to make the object we're talking about. And then from there, we go to the instructions. We want to mix it all together, like you mix the reactants in a chemical reaction. And we separate it into 36 cookies. And we might phrase this as in the reaction language we've been using so far, as like one cookie dough goes to 36 unbaked cookies. And then we bake them by applying heat energy over time. And the exact quantity of heat energy, because we have units of energy to work with, we could calculate the amount of energy imparted by what we would normally use, which is an oven at 175 degrees Celsius. And then we tell them to do this over the course of 8 minutes or for 80 seconds. We can specify time using, for example, a timed audio transmission.
Great. Next is the idea of weightlifting. Our communication schema does not really give us an idea of mass, but we thought using relational ideas and the concept of a self, which we've covered earlier, we could introduce energy divided by time, so power over time. So you doing work leads to a you greater than you were before, which is about as close as we can come to weightlifting, and it'd be really fun to see how they misunderstand that. That would be a blast. Finally, we had an interesting sentence, and the sentence we went with was, together we are greater than the sum of our parts. So again, we went with using relational operators, us together is greater than us apart, and we really hope they don't interpret that as an overture of war, but that's just the risk we got into when we started this project.
Yeah, and also as part of this, we decided to...
Unfortunately, your time is up. Were you close to the end?
I just was going to talk about what our computer model was. I'm going to pause on this page of all the dialogue I had with our computer module.
Y'all actually use like natural language processing too.